AI Trends Professional Research Report 2025 by Theorem AI, Breakthrough Technologies, Shaping the Future of Artificial Intelligence. Part 1. Recent News and Breakthroughs. Key developments driving the AI revolution forward. Revolutionary reasoning models transform AI capabilities. The artificial intelligence landscape has been dramatically reshaped by the emergence of advanced reasoning models, with OpenAI's O3 and O3 mini models leading a breakthrough in AI's ability to tackle complex, multi-step problems across various domains. These models represent a fundamental shift from traditional AI responses to systems that can think through problems more like humans would, using reinforcement learning to hone their chain of thought and refine strategies. The O3 model achieved remarkable scores of 75.7% on the semi-private ARC-AGI evaluation in low compute mode and 87.5% in high compute mode, marking a significant breakthrough in getting AI to adapt to novel tasks. This performance is particularly noteworthy, given that the ARC-AGI benchmark took 4 years to progress from 0% with GPT-3 in 2020 to just 5% in 2024 with GPT-4o. The competitive landscape has intensified with Google's response through Gemini 2.5 Pro Experimental, which debuted at the top position on the LM Arena leaderboard and achieved state-of-the-art results across various benchmarks. Meanwhile, China's DeepSeek R1 emerged as a cost-effective alternative, dramatically reducing computational requirements with training costs of just $5.5 million compared to hundreds of millions for competing models. However, these advances come with trade-offs. OpenAI's latest reasoning models hallucinate more often than previous iterations, with O3 hallucinating in response to 33% of questions on Person QA, roughly double the rate of earlier reasoning models. This highlights the ongoing challenge of balancing enhanced reasoning capabilities with accuracy and reliability. Next-generation AI chips drive performance leaps. The hardware foundation of AI continues to evolve at breakneck speed. NVIDIA's H200 Tensor Core GPU introduced 141 GB of HBM3E memory at 4.8 TBds, nearly double the capacity of the H100 with 1.4x more memory bandwidth, enabling inference performance nearly twice as fast as the H100 for large language models. The true game-changer is NVIDIA's Blackwell B200 architecture, featuring 208 billion transistors manufactured using TSMC's custom 4NP process, with 2 reticle-limited dies connected by a 10 TBS chip-to-chip interconnect. Early benchmarks show a single Blackwell B200 GPU achieving 10,755 tokens per second in server inference tests, approximately 3.7 to 4 times faster than a single H100 GPU. Competition is heating up with AMD's MI325X, featuring 256 GB of HBM3E memory and claiming a 20–40% lead over NVIDIA's H200 in inference performance for large models like Llama 3.1. The shift toward specialized silicon reflects enterprise demand for custom application-specific integrated circuits, ASICs, that offer higher efficiency than general-purpose GPUs. Liquid cooling revolution addresses power density crisis. The explosive growth in AI chip power consumption has triggered a fundamental shift in data center cooling strategies. Supermicro announced shipping over 2,000 direct liquid-cooled AI server racks by August 2024, expanding manufacturing capacity to 5,000 racks per month. Driven by NVIDIA's B200 chips requiring direct-to-chip cooling due to their high thermal design power exceeding $1 continuously, the liquid cooling market has surged from 7% adoption 3 years ago to 22% today, with projections showing unprecedented growth as air cooling reaches physical limits. 2025 marks the tipping point when liquid cooling transitions from bleeding edge to baseline infrastructure, supported by massive capital investments and strategic partnerships. Comparative analysis shows liquid cooling can reduce carbon footprint by 87% and cost by 86% annually for large-scale deployments, while direct liquid cooling can reduce power expenses by 15 to 20% through elimination of energy-intensive traditional cooling methods. Innovation continues with Microsoft's development of AI-discovered PFAS alternatives and closed-loop, zero-waste cooling systems.